Alright, today we're going to talk about types of symmetry. So here you can see the kind of symmetry you're used to. On this figure you are noticing the typical reflective symmetry, split right there down the middle. Now with this being a square, I could theoretically also split it right through here. I could go corner to corner. Lots of lines of symmetry for this, for reflective line of symmetry. Now if you look at these arrows, they are not reflected. I can't draw a line and have a line of symmetry anywhere, but I can see that these shapes are congruent, but it looks like one of them has simply been rotated. So if I were to take this and I were to take the back side here and the front side there, if I were just to rotate it along a circular axis, I would end up going this way. And then if I were to keep rotating it, might point up, and then keep rotating it, it might point left. But right now I went from pointing down to pointing right, so I rotated. Now here I've got two identical or congruent circles, as we see in our terms to know down here, but one is just moved. I mean, I could theoretically draw a line of symmetry here, but we know these are two different figures. So what I actually have is I have one figure that has just been slid down here. It's slided down here. It actually, we're going to call that translated down here. So when we translate something, it just slides along an axis. So we can picture if this was the middle and there was a line that went down here, we took this figure, copied it, and just like that. I could also do it another direction by rotating them. If I started this way, and here was my center point of axis, I could slide it across this way. So if we just slide it across an axis, two different objects slid across an axis, we call that a translation. And our last type of symmetry is this one. You see we have the letter R here, but over here it's like flipped upside down and it's slid across. So it's kind of, working in a pattern where it's the same figure, they are congruent, but it's upside down. It has been changed, and then it's back up and down, and we see this a lot in plants and things, as I'll show you on the next slide with pictures of each of these. This one has a special name. We call it a glide. So here's another cool image I just found online, which is available. And you can see that it has the symmetry types and a reflection. You can see in this anchor is when I could literally, it looks like a mirror image. So reflection is like a mirror image. I fold it along that line of symmetry and I would end up with one new image, but they would match up perfectly. The translation, I just took a figure, a congruent figure, and moved it. I slid it down, maybe I slid it across, maybe I slid it up. In this case, it looks like it had slid down, unless this was the first it slid up. But a translation literally just slides it from one direction, from one place to another. Now the rotation here, we can see the figure here has been turned. So they put the bottom side up and the right side down, so it has just been turned around along a circular axis. That's a rotation, and rotation's easy to remember because it looks like it's gone on a circular axis, just like a reflection. Translation might be the tough one. And a glide translation is when it's like flipped upside down and moved over. Now, I'll show you a real example of this with the next picture. In this picture, we can see that the hand has been reflected along this line, but it has then slid over. So it's not just rotated, it is a reflective symmetry with a slide or a translation, so we call that a glide. So like this one up here, if we zoom back in on the R, right, we can see that there could be a line of symmetry right here, and it's been reflected, but then it has slid over. So if it has a reflective line of symmetry, but it's been moved, we will call that a glide. All right. Some people call it a glide translation. Some people call it a glide reflection, but it's a mix of reflection and translation. Here's another example of a glide. You can see that the leaves, and we see this a lot on plants, if I were to stick this leaf and scoot it to the left, that it would be a reflection. But it's been reflected and then translated as well. So it reflects and translates. We call it a glide. So this would be glide symmetry here. So here's a quick example of one I can make, so you can see it not just in real life terms, but in making. So if I had this figure, and I wanted to show a glide translation or glide reflection, I'd have to reflect it, so it would look like this, but then I would also have to translate it maybe like that. So that is a glide. It reflects, then it slides or translates. So here's some more reflections. Basic things we see all the time. We've got McDonald's. We've got a line of symmetry right there down the middle. Okay, flipping it from left to right. So it has a line of symmetry that goes up and down. Then we have the, I don't know what this is, but pretty cool little art piece there. Reflective line of symmetry going up and down. This cool looking bird has a clear line of symmetry from its head to its tail. You can see there. Batman's logo has a line of symmetry from head to tail. You can see right there. The picture of this bridge has a line of symmetry. You can see that right there. And this flag, or symbol from the flag, you can see has several lines of symmetry. I could do it right there. I could draw one across like that. I could make one diagonal right there. Or I could make one diagonal going left to right. Several points of symmetry on squares that match up that way. So reflective symmetry is all over us. It's all over the world. It's everywhere we look. It is in lots of arts, architecture, animals, people. Speaking of people, Photo Booth has a mirror option where you can take a picture of yourself along a line of symmetry. And so you can see my line of symmetry would just go right down there. And it obviously matches up in this picture that shows somebody. But that's a pretty cool function. On your iPad in Photo Booth, there's a mirror thing where you can practice symmetry on things all over the place, including yourself. I think a translation is probably an easy one, like reflection. It just slides. You just have to connect the name translate with just moving it up and down on a certain axis. And that would be as simple as, making a copy of something and moving it along that axis. So you can see that this would be a translation. But what I'm more interested in is the rotation. I think the rotation can be a lot of fun. And so something you can see done on a rotation is like this. So you can see that I'm simply rotating this figure. Now, obviously, rotating isn't a type of symmetry, but if there were two figures and one of them was facing one direction and the other one was facing the other, and it was clearly rotating along a line of axis, a circle of axis, as this is, it's basically just rotating right around here. This would stay still, everything's rotating right around it, and I had it facing up right there, and then I took another figure like this and I started to rotate it. You can see it's rotating, but I could stop it, let's say right there. That's clearly a rotation. Same figure, just rotated. I can do it a little slower here. Let's try it a little slower. Let's stop it right about there. So that would be a rotation. I could even keep going if I wanted to. And boom, rotation. So that's just a rotation. Now if I were to change to a figure like this one over here that isn't, perfectly symmetrical up and down. This would be an example of a rotation, but if I flipped the figure on the right like this, what I've done is I've made a reflection, as you can see here. So that would be a reflection type of symmetry, but then I could also move it, and now I've done a glide. So I showed rotation, glide. Translation would simply be if it was not flipped, but was like this and slid over. So those would be our 4 types of symmetry. So to wrap up, quick review, 4 types of symmetry. The one we're used to, kind of grew up with, A reflection along a line of axis, mirror image on both sides. A translation simply slides or moves along an axis but takes a congruent figure and puts it somewhere else along a certain plane. A rotation actually turns the figure to face a different direction. It rotates it along a circular axis. And a glide is a mix of reflection and translation where it reflects it but then it slides it as well. So a glide is a mix of reflection and translation, and those are our symmetry types.